I'm alive. We're going to look at some applications of the normal distribution. This is like the most useful thing I think about statistics is understanding the normal distribution and how it relates to probability. Now we have a completely fabricated example here. It says the AP calculus test results have an average grade of 70, so that's my mean, with the standard deviation of 10. So this thing is the population of tests. It's everything. What's the probability that a randomly chosen test has a grade between 80 and 90? There are two big assumptions that we're making here. So the assumption one is that this is a continuous distribution, or maybe this is assumption two. I don't think it matters which order they come in. And obviously, we know that is a fallacy because this is discrete. You get 88 or 89 or 90, and that's it. Now, the second assumption is that this follows the normal distribution pattern, and this could also call into question our method because often test scores do not follow a normal distribution, although they might, or a normal distribution might be a reasonable estimation of the way the scores are distributed. Anyways, we're going to make those assumptions. You can see that the fact that we're assuming it's a normal distribution introduces a complete fallacy because that would assume that you indeed could get a mark beyond 100. So you could get a mark that was 4 standard deviations above the mean, and that's completely impossible. So there's a few of those assumptions that we're going to make just to make things simple. Okay, speaking of making things simple, you'll see that the interval that we're interested in is 1 standard deviation above the mean, and the second one is 2 standard deviations above the mean. So just know how to calculate the Z-score. So Z1 is 80. So the score minus the mean divided by the standard deviation. And so that's just a Z-score of 1. And Z2 is 90 minus 70 over 10, and that's equal to 2. There are 2 ways that you can do this. If you've got GeoGebra sitting in front of you on a laptop, you just move those little bars and you find what the area is between a Z-score of 1 and a Z-score of 2, and GeoGebra does that nicely for you. The more likely scenario, if you're in a test, say at university, is you have to look at it out of a table. And so you've got these tables and they have Z-scores correct, and if you have to know how to read the table, correct 2 decimal places, but they tell you what the Z-scores are. Now, what we are interested in is this area between a Z-score of 1 and a Z-score of 2. So what's the probability that that's a Z, greater than 1 and less than 2, and that's a 2, and that's not a Z. Okay. If you were to look in that chart, you would actually find that you're only told the area to the left of a particular Z-score. Some charts, they have it like from the mean to a Z-score. The one you're going to be looking at only tells you the Z-score to the left, so you just look it up on the table, which I have done. So the area under the normal curve to the left of a Z-score of 1 is 0.8413. So a score of 80 in this example would be, there would be 84% of the tests would be less than an 80. And a Z-score of 2, so this is our 90, this is actually 0.9772. Okay, so I know how many are to the left of 1. I know what percentage are to the left of 2. The probability that it is between 1 and 2 is just 0.9772 minus 0.8413. Oh my goodness, I can't do that math. Oh wait, maybe I can. I don't think I've got any carries. Oh, maybe I do. Anyway, maybe I don't care. I'll leave that to the viewer to calculate. But as you can see, it's roughly 0.135 or something like that. So there's about a 13% chance that if I just randomly reach in there, I'm going to be pulling out a test that's between 80 and 90. Everything else, provided it's a normal distribution, or a reasonable estimate, and it's continuous. So things, particularly biological things like apples and soybeans and head size and things like that, often follow that normal distribution. And this is a fantastic tool for finding out what the probability of getting a particular result is if I know the parameters of my population. That's that.